Alright, so this is part 2. We're going to continue on where we left off with number 9. And we have t squared plus 0.6t plus 0.09. Now, the decimals do cause a little bit more work on our part, but not really much. The t squared has a leading coefficient of 1, and the GCF between all the terms is 1. So we're going to go straight ahead and find factors of c, which is 0.09, and see what factors of c is the sum for b. Since there's decimals, the decimal point has 2 places, 0.09, and the b term has only 1 decimal point. We're going to take a wild shot here, and generally this is a good idea, where our 2 factors we're going to write whatever one number of a factor of 9 times 0.1 factor of a 9, and when they multiply together, since there's 2 decimal places, we'll end up moving over 2, so we'll have 0.09. So like 0.1 times 0.9 is 0.09, and another one we could have is 0.3 and 0.3. And now we just have to figure out, okay, sine of b determines the signs. Well, b is positive, so our bigger factor should be positive. C is also positive, so actually both factors are positive. Now we need to figure out whose sum is 0.6. And the only one that works is 0.3 and 0.3, which is in fact 0.6. So since this is a leading coefficient of 1, we write t plus 1 factor times t plus the other factor. So one factor is 0.3, and the other guy is, 0.3 again, right? So since it's the same exact thing, t plus 0.3 times t plus 0.3, we can write this as t plus 0.3, that quantity squared. And now if we look at our options, well, b and d are silly. And a is a little weird. We have t squared going on there, which makes no sense because t squared times t squared is t to the 4th, and that's not what we started with. So the only one that does in fact work is what we got, which is t plus 0.3, that quantity squared. The next one, 10. We have 20z squared plus 7z minus 6. Now, when we look at this one, we see there's 3 terms, so it's a trinomial. There's no GCF, unfortunately. So there's an a term other than 1. That means we're going to have to use AC method. Now, you don't have to use AC method. You can do the FOIL method, which we learned in 13.3. AC method is 13.4. You can use either or, and I stress the AC method more because it's, well, what I always say is the quick and dirty way. So what you do is you take the a, which is whatever's in front of the squared term, so 20, times it by your c. In our case, it's negative 6. That sign comes with it. And we got negative 120. Now, we need to find factors of negative 120 whose sum is 7. And that might seem like a little bit of work, but what we're going to go ahead and do is start with things that are close to one another. Because 7 is such a small number, we don't want a big range between our numbers. Like 1 and 120 is just ridiculous. There's no way we could get 7 out of that. But if we try to be a little bit reasonable, like 10 and 12, well, the difference between these two is 2. Not 7, but at least it's a little bit closer. And we could keep on trying, maybe, I don't know, 8. 8 goes into there, I believe, 15 times. Yep, it does. So we have 8 and 15, maybe is another one. And you know I've already done this before, and it just takes a little bit of guess and check. If you ever have issues, remember you can always resort to listing out from the beginning. 120, you got 1 and 120, 2, 3, 4, 5, 6 can go in there, 7 can't, 8, and keep on going down the line until you hit someone who does work. As you get more used to these problems, it really will be your strong suit for your multiplications that will save you. 8 and 15, we kind of should have a good idea of figuring that out so that we could see the 7. And the sign of b is positive, so we want the bigger factor to be positive, and since c is negative, we want the other factor to be negative. So, negative 8 plus 15, sure enough, is 7. Now, AC method. This is not the same as before. So we're going to do the quick and dirty way, in which we're going to list out our A term twice. Now, you and I both know that this is technically not correct, because 20z times 20z is, 400z squared, which isn't 20z squared. So we already know it's not correct, but we will undo this extra multiplication we have going on, okay? So let's fill in our factors. We have minus 8 and plus 15. Now, negative 8 times 15 is negative 120, not negative 6. So we have to fix this. And how we fix it is by dividing out the GCF between each of them individually. So between 20z and 8, the GCF is 4. Between 20z and 15, the GCF is 5. And you might notice, for those who like the patterns out there, 4 times 5 is 20, which is that extra 20 we have going on there that causes everything to be offset. So we're getting rid of it now. So we're left with, almost wrote 20z again. We have 5z minus 8. I messed up. Each term has to be divided by the 4. So it's 5z minus 2, right? 8 divided by 4 is 2, not 8 again. And 20 divided by 5 is 4z plus 3. And let's see, 5z times 4z is in fact 20z squared. Negative 2 times 3 is negative 6, so we're winners. Now we just got to figure out which one of these is our answer. Well, A is silly talk. We know it's not prime, we just factored it. And now we just got to be careful of the signs. It's 4z plus 3. That's what we have. So B's our winner. And there we are. Next one, 11. We have 10y squared plus 45y minus 25. Now this is a nice guy because there actually is a GCF we could factor out. We have 10, 45, and 25. Then ends in a 0, ends in a 5, ends in a 5. I bet 5 is a GCF. Maybe something more, but 5 for sure. 5 times 2 gets us 10. We need the y squared. 5 times 9 is 45, and 5 times 5 is 25. So there's where we get this. Now this new polynomial that we're looking at has a leading coefficient of 2, which makes us have to use the AC method again. So we take the 2, we times it by the 5, well, negative 5, because the c term's negative, sign goes with it, and we have negative 10. Now, negative 10, we got to list out factors whose sum is 9, and you're probably screaming at me for your computer saying 1 and 10, 1 and 10, and you'd be right. So, in fact, now we got to look at the sign of B to determine our sign of factors. 10 must be positive, and the 1 must be negative because we need a negative times a positive to get us a negative. So there's our factors. Now, the AC method says repeat what your A is. So we're going to repeat 2y twice. And we know this isn't right because 2y times 2y is not 2y squared, it's 4y squared. So we're off by a multiple of 2. But we'll fix it. Now we add in our factors, minus 1 plus 10. Now, between these two, we have to find the GCF. And it's 1. Boring, right? Alright, between the other two. Oh, it's 2. So we got something interesting. So this guy stays the same because he doesn't change. It's 2y minus 1. I hope that's on screen. And the next guy is y plus 5. And we have factored it. Now, the only thing we can't forget is our GCF. And don't worry, the multiple choice wouldn't let us, but on our free response, we don't want to forget our GCF. 5 is still floating out front, right? Don't want to forget him. So, when we pick it, our answer, only one that's right, is C. 12. We have 15z to the 4th minus 11z squared minus 12. Now, once again, it's that z to the 4th, z squared business, just like the p to the 4th and p squared. If we pretend this was instead 15x squared minus 11x minus 12, this problem would be much nicer for us. You'd probably right away know, oh, AC method, I can do this. Now, you just have to start getting used to the fact that when you see the b term as z squared and the squared term as the squared version of it, so z squared squared is z to the fourth, then we're going to pretty much pretend it's x squared x. Okay? We're going to get in the habit of trying to think of it that way. These problems don't happen too often, but I wanted to expose you to them before you saw intermediate algebra. It won't be something on your final, though. So don't completely write it off, okay? It will be on your test, but it won't be on your final. Now, I'm going to go ahead and, for funsies, visit the old FOIL method. It's going to be painful, but I'm going to do it anyways because I'm sick. And notice how they actually gave us a lot of the options for the FOIL method in our multiple choice. So let's see. I see lots of 3s and 5s. In fact, that's what some factors of 15 are. 3 and 5 and 1 and 15. And now we can find factors of 12, in which we have 1 and 12, 2 and 6, 3 and 4. Okay? And maybe I should, for safety, write 1 and 15. Now we can be smart about this. Let's look at our signs to help us out. The b term is negative. So that means we want the larger factors. Oh, what have I done? Don't do anything to that thing. Go back to the pen. We want the larger guy to be negative. And since this is negative, I didn't write that. Shame on me. The other guy has to be positive. Now let's see. We're going to take the factors of A and use them as our starting ground. We have 3x and 5x. Could also have 1 and 15, but notice they didn't even bother with it. Chances are, because 11 is so close to 15 and 12, we don't want to use a big range. Like 1 and 12, we could already start throwing them out. I mean, if we have to come back to him to make sure if things start looking prime, we'll come back. But for now, he seems almost kind of silly to experiment with. We could maybe experiment with the 2 and the 6, in which that gives us 2 options right there. Or maybe we have the option of the 3 and the 4, which gives us another 2 options. Now, I'm not cheating and using my multiple choice here because, remember, you're going to have free response. Can't remind you that enough. But just to be safe, I'm going to list down options that seem logical. Now, remember, all we have to do here is check the inside, the outside and inside. We already know the first and the last work because we did 3 times 5 is 15. We know 2 times negative 6 is negative 12. So we know the first and the last work. We're concerned about the outside inside. So let's start, we'll call him number 1 here. We have 3 times negative 6 is negative 18. We'll call him number 1 over here because I don't want to get all over the place on you. X. Now the inside, 2 times 5, that's 10x. And negative 18 plus 10 is negative 8x, which is no good. All right, so option 1 is out. Let's try 2. So we have 3x times 2x is 6x. Negative 6 times 5 is negative 30, which is negative 24. Yep, negative 24, no good to us, so that's out. And now we'll check this third one. We have 3 times negative 4 is negative 12x. 3 times 5 is 15x, and that's total of 3x, which is also no good to us. So now we're going to start hoping that this is the case, or maybe we have to go back and revisit 1 and 12 and the 1 and 15 cases. We might have screwed up. And we'll see. 3x times 3. What's that? 9x. Alrighty, good. So we have 9x. Negative 4 times 5 is negative 20. And 9x minus 20x is negative 11x, so we are winners. Now, you're probably going, well, you have x's. We were z's. Okay, you're right. I'm sorry. So let me go ahead and rewrite this. Instead of x, we should be viewing it as z squared, right? because we were calling x really z squared minus 4 and z squared. I said it, but I didn't write it. Let me try again. Take 2. Z squared plus 3. And let's see, the only one actually it's on screen right now is choice D. That looks exactly like what we have. Now you can use AC method too. It doesn't matter. I just figured you want to see, for old time's sake, the FOIL method. Alrighty, let's go ahead and see this next one. Alright, step 1. Is there a GCF? We keep forgetting it here and there, mostly, well, not we, I do, because it's not necessary, but sometimes it is, and we should always keep it in the back of our mind going, is there a GCF? And yes, 4A is the GCF here. In fact, you could even see in your multiple choice, everyone had that 4A sitting out in the front. Well, even without it knowing it, 4 can go into itself, 4 can go into 16, and 4 can go into 20. The smallest degree of the A's is A to the first, so there's our GCF. Now left behind, well, 4 times 1 gets us 4. We have 1A, we need 3 of them, so A squared, plus 4 times 4 is 16, and we need another A, minus, and 5 times 4 is 20, and we already have the A. Now, sometimes you think you're done, but you have to double check if you can factor the polynomial that's in the red further. The leading coefficient is a 1. It's an ugly 1, but it's a 1. So we are going to list factors of -5 whose sum is positive 4. Well, 1 and 5, in which 1's negative and 5 is positive, is our keeper. So when we write this, we don't want to forget our GCF. We'll have A minus 1 and A plus 5. Now we just have to find our option. Looks like go ahead, they had A plus 5 appeared first, and then A minus 1 with choice C. 13. The numbers just keep getting worse, don't they? So we have 15x squared minus 16xy plus 4y squared. When we look at this guy, there is no GCF. Bummer. So we're going to get to use AC method or FOIL method. Doesn't really make a difference. Let's visit AC method again. So their A is 15, our C is 4y squared. So when we multiply these two together, we'll have, I don't know, 4 times 5 is 20, and 60, and y squared. So now we need to find factors of 60y squared whose sum is -16xy. And now this actually is really nice use of the AC method. We'll see very nicely we have the y's, y times y is y squared, and our b term has the single y, right? Now 6 and 10 should kind of be immediate to us. The signs is where we're going to have a little work. It's negative. Now this is positive, so we have a positive here, and these two are going to be both negative in order for us to get the positive, and -6y plus -10y sure enough is -16y, which is exactly what we want. So now we need to repeat our a term twice. So we have 15, 15, and the x is coming along. Then we have -6y, -10y. Now, I don't know if you've ever wondered it, but you're like going, well, how do you know to put this guy first and this guy second? I could tell you right now it doesn't matter. That's why we write 15x twice. That way we don't have to worry about who goes with what. Because when we divide out the GCF, we fix all the troubles. So here the GCF is only 3. And the GCF here is 5. And sure enough, once more we can see that 3 times 5 is 15, and there goes away that extra 15 we had that was in the front. Makes life really, really nice. And now, when we divide it out, we have, 3 times 5 is 15, so we have 5x minus 2y. And for the other guy, we have 3x minus 2y. Now let's see. Oops, I gotta close my parentheses. Let's see if we got anybody who looks remotely like that. So we have 5 minus 2y. Well, these two have that. And 3 minus 2y. So the only choice is D. Our next one, we have question 15. It says factor by grouping. Now, this one is interesting because you might be thinking, well, I can combine like terms. In fact, this is another way we can sometimes work with AC, where we split up the middle term into two factors and then we factor by grouping. We're not going to go ahead and combine like terms. We're going to resist that urge. We're going to group the first two together and the last two together. So, between the first two, the GCF is 3x. Left behind is a 5x plus 6. Now that negative we don't like, so I'm going to factor him out. In fact, both terms have a negative, so let's go ahead and get rid of it. And 5 is the GCF, and left behind is a 5x plus 6. Remember, I factored out the negative. Negative times a positive gives me a negative. And this needs to be negative 30, so that's why we have to have positive 6. Be careful of your signs. Now we have a new GCF appearing, that 5x plus 6. So we'll factor him out, parentheses included. And what left behind is the stuff in the front. So 3x minus 5. And we're done. So now we just got to find the one that works, and choice A is the winner. The last one for this part, because my videos go a little too long, is another factor by grouping. And I know there's like terms, but we're going to group the first two together and the last two together because the directions are there to help us, not there to hurt us, okay? So the directions told us to do this. Now, once again, a little boring. Between the first two, we have a 3 and also an x now. So left behind is a 6x plus 5y. Now we got that negative business again, right? There's a whole nother negative there too. So we're going to factor out a negative. And I think the biggest thing we got going is a 2y. So left behind is a 6x minus 5y. And now, oops, I made a boo-boo. Actually, probably you could guess where it was. Right here. Negative times a negative is a positive, and I want a negative. So this should be positive. And I could already see my mistake when I went to compare my two new GCFs. If it was a negative, they would not be the same. So now I have 6 plus 5y, 6x plus 5y, being factored out. And left behind is the stuff in the front, which is a 3x minus 2y. And the only one that gives us that is choice C. And it seems to be a habit of mine where I have my order swapped constantly compared to the multiple choice. It doesn't make a difference because it's multiplication, and multiplication is cumulative. To keep YouTube happy, I'm going to end the video here, and the second page will be done also probably in 2 parts as well. So keep tuned.